Welcome back to WABC. So we can move to another session called Atomic and Nuclear Physics. Okay, so the first question is the photoelectric work function for photometal is 2.4 electron volt. Among the four wavelength, the wavelength of light for which photo emission does not take place. Okay, so what is the main working of this phenomena? When a photon of specific energy is coming to the metal and a work function is to be done by the wave to deploy a photon from the surface. Okay, so photon is coming, hitting the metal and it is ejecting an electron. Okay, ejecting an electron with a specific energy. Okay, so the work function is we can note it as phi naught. Okay, so the incident energy of the photon is E and the work function is phi naught, and E minus phi naught, which gives a h nu. That nu is the frequency of the ejected electron. Okay, with respect to that frequency we can find what is the wavelength of and what is the color, is it visible or not. Okay, whatever it is. So for 2.4 electron volt, work function is for 2.4 electron volt. Below that, the energy below that energy 2.4 electron volt, we can't observe any kind of photoelectric effect. Okay, so which one wavelength is will not give any kind of photoelectric effect. Okay, so higher the wavelength, lower the frequency. It will lower the photoelectric emission. Okay, lower the energy, which gives no photoelectric emission will not happen. So by logic we can assume that 700 nanometer is the wavelength which will not give any kind of, because this is the low frequency, this has a low frequency, so low energy, and 200 has the high frequency and high energy. So by logically we can select C, option C is the correct answer, but we can calculate that energy E is equal to h nu, which is equal to hc by lambda. Okay, and hc is when we calculate hc, that hc value is in joule, so we need to transform that hc value of hc into electron volt. So when we are changing that to electron volt, we can write this equation. After all mathematical calculation, we can write this in a simple equation, that is lambda is equal to hc by E, which is equal to after all calculation 12,400 divided by work function. These are in electron volt and these are in electron volt meter. Okay, electron volt meter, electron volt and electron volt cancel each other and the unit of wavelength is meter, so we get the answer. So in here the lambda is equal to 12,400 divided by work function is 2.4 electron volt. Okay, and it is electron volt meter and electron volt get cancelled, and the answer is approximately 500 something. Okay, so it will be 124 divided by 2 is 62 and the point for this, so we get a 50 something, and into 100 it gives, okay, approximately 500 something, but our wavelength is 700 nanometer, so we can't use that, because if we use that there is no ejection of electron takes place. Okay, because the minimum energy is approximately with a wavelength of 500 something. Okay, so that's why we can use that one. So option C is the correct answer. But in the exam you can choose the option in 10 seconds, because 700 has the lowest energy, the wave which have low energy. Okay, but if there is a group of waves, then you need to calculate. Okay, the next question, the second question. In alpha particle scattering experiment, if v is the initial velocity of the particle, so v is given as the initial velocity, then the distance of closest approach is d. If the velocity is double, then the distance of closest approach becomes. So we want to relate the velocity with respect to the distance of closest approach. So what is the relation between d and distance of closest approach? V square is proportional to inverse of d. V square is proportional to inverse of closest approach. So we can do the calculation as v1 by v2 the whole square is equal to d2 by d1. Okay, so the question is, then the distance of closest approach is d. If the velocity is doubled, so the velocity is getting doubled. So v2 is equal to 2v1. So 1 by 2 square equal to d2 by d1. Sorry, d1. So d2 is equal to d1. d2 equal to d1 by 4. d2 is equal to d1 is d, so d2 is equal to d by 4. Option D is the correct answer. So we can move to the third one. Okay, the ratio of area of first excited state to ground state of the orbit of hydrogen atom is the ground, which is the ratio between the ground state and the first excited state, and what the area. Okay, the orbit, area of the orbit. They are asking the ratio between the area of first and the ground excited state. Okay, so what is the relation between the area and n? N is the quantum number. So area is proportional to r square, because it is revolved around like a circle. So and when we check the magnitude, the units, it is r square. For area it will be r square. So area is proportional to r square, and r is proportional to n square. So area is proportional to n raised to 4. Okay, so area is proportional to n raised to 4, and first excited state n is 2 and the ground state n is 1. So a1 by a2 is equal to 1 by 2 all raised to 4. Okay, so a2 is equal to 2 raised to 4 into a1. Okay, so the ratio of area of first excited state to a1 by a2 is equal to 1 by 2 raised to 4. That means 1 is to 16. 1 is to 16. Option A is the correct answer. Okay, so because the question is the ground state to first the area of first excited state. So the area of the first excited is to be calculated. So a2 by a1. So actually they are asking a2 by a1, which is equal to 16 by 1. That means 16 is to 1 is the correct answer, and option A is wrong. 1 is to 16 is incorrect, because they are asking the ratio between first excited. So the upper sides will be the area contributed by n equal to 2, and the lower is the area contributed by n equal to 1. Okay, so a2 by a1 is 16 by 1, which is option D is the correct answer. And we can move to the fourth question. The ratio of volume of aluminum 27, okay, ZXA, that means the mass number M is given as 27. Okay, sorry, the mass number A is given as 27. The mass number A is given as 27, and its surface area, the ratio of volume to surface area. Okay, we know that every nucleus of a molecule or an atom, okay, nucleus of an atom is in spherical state. So what is the volume of a sphere and what is the area of a sphere? And the ratio of volume of a sphere is 4 by 3 pi r cube, and area of a sphere is 4 pi r square. So volume by area is equal to 4 by 3 pi r cube divided by 4 pi r square, which gives r by 3. Okay, the ratio volume to area is r by 3. What is r? R is equal to r naught a raised to 1 by 3 by 3. And a is 27. So r naught is given 1.2 into 10 raised to minus 15. So the ratio is equal to r naught. Ratio volume by area is equal to r naught. R naught is 1.2 into 10 raised to minus 15 multiplied by a is 27. 27 raised to 1 by 3 by 3. Okay, so 27 raised to 1 by 3 is just 3, because 3 into 3 is 9, 9 into 3 is 27. So 27 raised to 1 by 3 is 3. 3 by 3 we can cancel it. So it is 1.2 into 10 raised to minus 15. Okay, option D is the correct answer. So we can move to the fifth question. In the following equation representing beta decay, the number of neutrons in the nucleus X is. Okay, here the 83 is the what? The proton number. Okay, Z is the proton number, and it is bismuth. Okay, and proton plus neutron is 210. So the neutron number of bismuth is 210 minus 83, which is equal to 127. So there is actually initially there is 127 of neutrons in the left side. So by conservation of particles, we want an equal to 127 of neutron in the right side. But in the right side, there is an electron and a neutrino. An electron and a neutrino is generated. From where the electron and a neutrino is generated? It is from decay of one neutron. So one neutron is transferred to electron and a neutrino. So in X we have only 126 of neutrons. So option C is the correct answer. So we can move to the sixth question. Okay. In sixth question, a nucleus with a mass number 220 initially at rest emit an alpha particle. Okay, with a mass number means what? A is given as 220. Okay, mass number is A and atomic number is Z, and the normal representation of an atom is ZXA. Okay, Z is atomic number and A is mass number. X is the element. Okay, if Q value of the reaction, okay, Q value is given. Q value is equal to 5.5 mega electron volt. Okay, 5.5 mega electron volt. Calculate the value of kinetic energy of alpha particle. So we want an equation which connect kinetic energy and Q value and mass number. So I will write that equation: kinetic energy of alpha particle is nothing but Q into A minus 4 by A. Okay, Q into A minus 4 into A. What is Q in here? The Q is 5.5 mega electron volt, which is multiplied by A is 220. 220 minus 4 by 220. Okay, so which is equal to 5.5 into 216 by 220. Okay, which is approximately near to 5.5. And which option is very near to 5.5? That is 5.4 mega electron volt. And this A and C are very larger than 5.5, so that is incorrect. And 4.5 is very less than 5.4. Okay, so option D is the correct answer. And you need to focus on this equation. Kinetic energy of alpha particle is related with the Q value and mass number of the particle. Okay, if the mass number is very small, then the difference by the negative part -4 will lead. Okay, so but actually the particle with the heavier mass number is will gives the what emit alpha particle. To emit alpha particle, the particle should be mainly greater than 150. Okay, the mass number should be greater than 150 or like that. Okay, then we can move to the seventh question. A radioactive sample has half-life of 3 years. Half-life is given. So we can write T half is equal to 3 years. Okay. That means after 3 years, half of the particle will disintegrate. Okay. The time required for the activity of the sample to reduce 1/5 of its initial value is about. So, what is the time required to change the n0 to, that means initial number of particles, to 1/5 of the initial. Okay, so it will always greater than 3 years, and in options, all options are greater than 3 years. So, the only way to solve this problem is only to understand these equations. So, okay. So what is the basic principle of this reactants? That means disintegration equation. That is n is equal to n0 e raised to minus lambda t, and lambda is a constant. Okay. So first we need to understand what is the value of lambda. So for that we can substitute t half. T half is 3 years. So n by n0. N by n0 means what? N0 is the initial and n is the final. N is n0 by 2. So n0 by 2, which is equal to n0 e raised to minus lambda t. So n and n0 and n0 can be cancelled. So 2 is equal to e raised to lambda t. So ln2 is equal to lambda t, and t half, this is t half, so t half is 3. So lambda is equal to ln2 divided by 3. Not the point, lambda is equal to ln2 divided by 3. We can put that in a box and we can put it in here. We can delete all the first calculations and we can start a new calculation for 1/5. Okay, so that means n is n0 by 5th. n0 by 5 is equal to n0 e raised to minus lambda t. We need to find the lambda t. Okay, so n0 and n0 is cancelled, and 5 is equal to e raised to 5 is equal to e raised to lambda t, just lambda t, there is no minus. Okay, so by taking the taking the logarithm on the both side, ln5 is equal to lambda t, and t is equal to ln5 divided by lambda, and lambda is what? ln2 by 3. So t is equal to 3 into ln5 by ln2. Okay, ln5 by ln2 is approximately gives 7 by 3. Okay, approximately it is 7 by 3. You can calculate it. It gives approximately 2.33 like that. Okay, 2.333 like is multiplied by 3, which gives 7. Okay, so the answer is 7 years. Option D is the answer, 7 years. So we can move to the next question. Okay, the radius of hydrogen atom in the ground state. Okay, the radius, we are discussing about the radius of hydrogen atom in the ground state is 0.53 angstrom. After collision with an electron, it is found to have a radius. That means the radius increase. That means the electron get an energy by bouncing with an electron. Okay, its radius is 2.12 angstrom. Okay, the principal quantum number n of the final state of the atom is, so we want to calculate the n. Okay, so what's the relation between r and n? R is proportional to n squared, so r1 by r2 is equal to n1 by n2. Okay, and n1 is 1, n2 is, we can take the root on the both side. So n1 by n2 is equal to r1 by r2 of root of R1 by R2. So N2 is equal to N1 into root of R2 by R1. Okay, R2 is nothing but 2.12. Just multiply N1 into 2.12 divided by 0.53. Okay, so 2.12 divided by 0.53 is 4, root 4 is 2, so N2 is equal to 2N1. Okay, so N1 is in the ground state, that means 1, so 1 into 2 is 2, so option D is the correct answer. For the 8th question, option D is the correct answer. And we can move to the 9th question. In accordance with the Bohr model, okay, so the concept is about Bohr model. The quantum number that characterizes the Earth revolution around the Sun in an orbit of radius 1.5 into 10 raised to 11 with the orbital speed, and the velocity is given 3 into 10 raised to 4 meter per second. That means the velocity of Earth which revolves around the Sun is given, and the radius is given 1.5 into 10 raised to 11 meter. Okay, and the mass is given, mass of Earth is given as 6 into 10 raised to 24 kilogram. Okay, so mass is given, radius is given, and speed is given. So with respect to these all quantities, we want to calculate the number of quantum number which the Earth is revolving around the Sun. It is similar to the nucleus, the electron which revolve around the nucleus. We can say that the Earth is revolving around the Sun, similar to that of electron is revolving around the nucleus. Okay, for that the electron has a quantum number n, principal quantum number n. Similar, we can, using that equation, we can derive in which orbit, in which principal quantum number does the Earth is revolving around the Sun. Okay. For that we need an equation. Which equation? I will write a relation. M V naught R is equal to NH by 2 pi. NH by 2 pi. So this is related the angular momentum of the particle. Okay, this is equation which connect which n and velocity and mass and radius. Okay, so from this equation, what is n? N is equal to 2 pi by h into m v naught r. Okay, substitute the values. N is equal to 2 into 3.14 into mass. Mass is 6 into 10 raised to 24 multiplied by velocity. Orbital speed is 3 into 10 raised to 4 and radius is 1.5 into 10 raised to 11. Okay, divided by h. H is 6.626 into 10 raised to minus 34, Planck's constant. Okay, so we can take all the multiplicand to one side. 2 into 3.14 is 6.28, is multiplied by 6, is multiplied by 3, is multiplied by 1.5, divided by 6.626 into 10 raised to, okay, 34 plus 24 is 58, 58 plus 4 is 62, 62 plus 11 is 73. Okay, we can approximately we can cut these values, and 3 into 1.5 is 4.5, 4.5 into 6 is approximately 4.5 into 6, 4 into 6 is 24, so 24 by 24 and 3 is 27, so 2.7 into 10 raised to 74 is the approximated value. See, 2.57 into 10 raised to 74. So option 2 is the correct answer because it has a power of 10 raised to 74, and the other has the power is too far away from this 10 raised to 74. So we can cut these all options. Option 2 is the correct answer. So we can move to the 10th question. If an electron is revolving in its Bohr orbit, having Bohr radius of and Bohr radius is given in angstrom, okay, 10 raised to minus 10 of meter, then the radius of the third orbit is, okay, this is very simple, third orbit, okay, which equation connecting this, the radius of the third orbit. The third orbit means and radius is proportional to n square though, so n is 3, so 3 square is 9, so 9 is just multiplied by 0.5 angstrom, which is equal to 4.5 of angstrom. So option A is the correct answer, 4.761 angstrom. Okay, thank you.